In this video, we're going to talk about 6-4 amplitude and period of sine and cosine functions. So we're going to take our sine and cosine functions from last class, and we're going to talk about what if we start to add stuff onto them. Okay? So when I say add stuff onto them, we're going to talk first about amplitude. So amplitude is the height from the mean or the rest value of the function to its max or min. When I'm talking about that mean or the rest value, we're thinking about like where the x-axis normally is, that line that we do our curve up, down, and around from, where our zeros are. This A, the amplitude is signified by an A out in front of our trig functions, okay? And the amplitude is just the absolute value of that A, so that the positive or negative of that matters in a different way, but not when you take the number value. So we just care about the numerical value. So how you can find the amplitude is you can take your A at the top, your A at the bottom, and divide it by 2. This right here, this is that midline, the mean or the rest value here. We'll also call it later our midline. And that's that point where we are going up, down, and around from, kind of like what our x-axis would be. Our amplitude is measuring from that middle point what the height, the highest point and the lowest point is going to be. So you count from your midline to add in your amplitude. All right. So I have a function right here. It says state the amplitude for the function y equals 4 cosine of theta. So on here, our amplitude is going to be 4. Okay, so that's right here. So that means from our midline, we're going to go up 4 instead of up 1, and down 4 instead of down 1. So right here it says graph y equals 4 cosine of x and y equals cosine of x on the same axis. I didn't leave myself very much room here, so we're going to make this go by 2's. Right, so if I do my regular cosine of x, let me go grab a pen to write on here for you. If I do my regular cosine, we're going to start up here at 0, and we're going to go, whoop, our cosine starts up, so it's going to go down, down, back up. This pen is not going to cut it for me. Back to that halfway mark. Okay, so that's kind of what my cosine is going to be like. Let's see if I can get it to go in this pencil. So it'll be down, down, halfway mark. Okay, so this is what my cosine of a half is going to look like there. So y equals cosine of theta. All right. Now if I want to do 4, so instead of us starting here at our top of 1, we would start up here at our top of 4. And we would go down and then back up. And our curve would look something like this. So this one is y equals 4 cosine theta. So when we have an amplitude, it's just changing the min and the max. Okay? So if we're comparing the graphs, we are just looking at the difference between the min and our max. If you want to take a look at the graphing calculator exploration on 369, it's going to help you do a little bit of exploring with that. If you were to have a half, okay, you would only go up then halfway. That's how that one would work. All right. Our period here is this K that is inside here. Okay. So the period of our functions, y equals k of theta or y equals k of theta, is 2 pi over k. So this number here, where this k is, we would put it to 2 pi over k, and that would tell us what the new period of our function is. So the location of the k is where we find the number that has to do with our period. Okay, so we're talking about this k, and then we need to plug it in to this thing right here. Okay. So right here it says state the period for the function y equals theta over a half. Okay. Well, our k here is equal to 1/2. And so now I'm going to put that into 2 pi over k, or 2 pi over 1/2. Let's change this out to 2 pi divided by 1/2, or 2 pi times the flip of it. So our period would be 4 pi. So that means instead of doing our cosine function in 2 pi, we would stretch it out and it would happen over 4 pi. Okay, so draw our new graph here and our cosine graph. We still have a amplitude on this one of 1. It didn't change any up and down, but now I got to take a look at how my graph is labeled. Because this one happens in 4 pi, and you think of your spots up, down, and back around happening in 4 different places, we are going to actually label this one in units of pi. So I have 2 pi, pi, 2 pi, 3 pi, and 4 pi. Okay. So I need to start by graphing my regular function. That means that this right over here is pi over 2. Those are my halfway points. Cosine starts at the top and it's going to head down and meet back up on those halfway points. Okay, so that one is y equals cosine of theta. Hopefully you can see that. All right, on this one now, pi over 4, that means my whole graph has to end up back here, which means we're going to start at the top, end at the top there. That's where it happens in. My midway point for my cosine is this bottom. Okay, so that means that for my cosine of 4, I'm going to go here and hit this point and come back around here. Okay. I know instead that that 4 pi happens every pi units instead of half units because my period is twice as big. All right. So here this says, use the parent graph for cosine and sine and adjust using the amplitude and the period for a period of 2 pi over k. So it says state the amplitude and the period and then graph the function. So these are the things we know here. I know that my amplitude equals a half. And my period is going to be 2 pi over k, and my k is 4. Okay, or this is pi over 2. So on my graph here, that means that my entire graph needs to end by pi over 2. So I'm doing a sine function. So that means my up, down, and around needs to end up at pi over 2. I'm actually just going to graph my regular sine function because it's not moving at all. And I'm going to go up, down, and around, and I need that to end up, and right here it says it ends up at pi over 2, so I'm just going to make that pi over 2. If that's pi over 2, that means this middle one right here, that's going to be pi over 4 because it's the middle point of it. Okay? Now if I'm looking here, my amplitude was a half, so this is a half. This is negative a half. So then 1 and negative 1. And there's my graph. So a lot of my amplitude and my period just has to do with labeling my graph and labeling it correctly. Okay, the next one says, write the equation of the cosine function with an amplitude of this and a period of 6 pi. Well, I know my amplitude is 9.8. And I need to find my period. I know that period equals 2 pi over k. I need that k in order to fill in that 9.8. So I'm going to say period is really 6 pi over 2 pi k. I'm going to flip-flop my 6 pi and my k, so I'll have that k equals 2 pi over 6 pi. And now I'm going to reduce this, so k is equal to 1/3. And now I'm going to plug that into my equation. So I'm going to have y equals 9.8, because that goes in front of it, cosine of theta over 3, because that k is attached to that theta. Right. The problem is, though, here is, what if our sign, what if the a is negative? What happens if there's a negative in front? Okay. So this is what's going to happen here. It's going to actually flip our entire picture upside down. So right here with our sine graph, it is going to take my sine graph and it is going to flip my sine graph upside down. And now this graph here that I graphed in black is going to be y equals negative a sine of theta. So almost everything stays the same. It just takes my graph and flips it upside down. I still have my same period. I still have my same amplitude. So that means actually up above here, we need to add a plus or minus. We'll just do that in front of our graph, because this X describes the positive or the negative, the flip or the regular of that graph. If I'm going to do my cosine, it's going to be the exact same thing. It's just going to flip it upside down. So the starting points are going to change location. So just kind of a heads up as you're working. Last thing, our period represents the amount of time that it takes to complete one cycle. The number of cycles per unit of time is known as frequency. Period, which is time per cycle, and frequency, cycles per time, are reciprocals of each other. You'll see they are the opposites of each other. So right here are some equations for you about period and frequency and hertz. So one period, a period equals 1 over frequency, a frequency equals 1 over period, and a hertz is 1 cycle per second. So I have an equation for you, a problem. It says write an equation of the sine function, so we need that, the sine function that represents the initial behavior, the vibrations of the note G above middle C. Music and trig. Having an amplitude of 0.015, okay, so we have that, and then having a frequency of 392 hertz, okay. Well, frequency is 392. And that is what our period is equal, 1 over our frequency. We know that period is really 2 pi over k, and frequency is period is equal to 1 over our frequency. And so now we're going to solve that, and that is going to give us the k that we need for our problem. So I'm going to cross multiply here, and I'm going to end up with k equals 2 pi times 392. I'm going to leave this in pi format, so I'm going to say 784 pi is my value of k, and now I can plug that into a sine function with an amplitude of that. So I'm going to say 784 pi t. because that is our time. So that'd be our equation there. Okay. The reason it's going to stay this way instead of negative has to do with how I think the music works. All right, that's it.